All right, welcome back. The title of today's lesson is Translation, Dilation, and Reflection of Parent Functions. Okay, so parent functions. The notes that I gave you guys in class dealing with all 10 of your shapes. You've got your linear, your quadratic, cubic, quartic, etc., etc. There were 10 of these parent functions that you guys were supposed to memorize as far as shapes. Today we're going to be learning how to translate, dilate, and reflect. Well, let me be more specific. Today we will be just focusing on translation. The next video we will focus on dilation, reflection, but I will go ahead and tell you what each of these means. Translation is a slide. Translation is a slide. Dilation is a stretch. And reflection is a flip. Okay, so we're going to focus today just on slide. Okay, in the next video we will deal with stretch and flip, or dilation, reflection. But before we get started, maybe sum it up like this. We're going to learn these concepts with respect to one particular function first, namely the absolute value parent function. I will then show you how to generalize or use these in many of the other parent functions as we get going. Okay, so first, today, you guys need to know, well, you should already have this in your notes, absolute, we're going to get more specific though, absolute value parent function. Okay? And it's the parent function of a family. Okay, so we have the absolute value parent function is the parent function of a family, and we think of all the members of this family as having the same shape and size as the parent. Okay, let's start with the equation. Absolute value parent function again is y equals absolute value of x, and now I'm going to give you guys be more specific about where the points on this function are located. Now you know that the absolute value parent function is v-shaped. Okay, but let's be more specific. Now in the next video, I'm going to go much more in depth and develop the locations, or where these points actually come from. Like, what does all this mean? Or where are we getting this? But today I want you just to memorize. We have points at 0, 0, 1, 1, 2, 2, and 3, 3, negative 1, 1, negative 2, 2, and negative 3, 3. And we're going to graph this. Okay, it's V-shaped again. And we have to know specifically where these 7 points are located. Okay, so let's go ahead and write the locations. This bottom point, or the bottom of the V, is called the vertex. It is the most important point, so let's label it the vertex. Its location is 0, 0. Okay? This point is located at 1, 1. This point is located at 2, 2. And then we have 3, 3. This point at negative 1, 1. Then negative 2, 2. And negative 3, 3. Okay, so you have to know where each point is located on the parent. So again, 0, 0, 1, 1, 2, 2, 3, 3 forms a V shape. Okay, now, again, we're dealing with absolute, this is the absolute value parent function, okay, and we're looking at the members of the absolute value family. Okay, so all of the functions that we're going to graph are going to have the same shape as the parent. Now, we're going to start with a member of this family. We're going to start with y equals the absolute value of x minus 2. Notice, okay, what is around the x minus 2? Notice you see the absolute value bars. This is what places this function in the absolute value family. So I'm just going to write here at the top. We are dealing with absolute value family. You can think of these as family members. Okay, and the family members all resemble one another. They look alike. Okay, so all the members of this family are going to look like the parent. So again, y equals the absolute value of quantity x minus 2. Now I want you to notice there's something different about this original parent function and the function in the family given here, the member. Okay, notice in the parent function we just have absolute value of x. In this family member we have the absolute value of the quantity x minus 2. So you notice 2 is being subtracted from x inside the absolute value. What this results in, okay, is a translation. Again, I've already told you translation is a slide. Okay, and we are sliding where? 2 units right. Okay, so this results in a slide 2 units to the right. What this means is that every point on the parent function will slide 2 units to the right. So what we're going to do, and the directions for the homework are as follows. First, on a piece of graph paper, you guys will draw the parent function first. Okay, so the parent function is located at, well, let's put these points again. We have this memorized. At 0, 0, 1, 1, 2, 2, and 3, 3. Negative 1, 1, negative 2, 2, and negative 3, 3. A little off. Okay, close enough. Let me make these points. Yeah, these points hopefully are clearly visible on the camera. The video camera quality is not as good here at home as it is at school, but hopefully you guys can see. Now, so we have 7 points. And what this minus 2 inside, when 2 is being subtracted from the x, inside the absolute value, this results in a translation 2 units to the right. What this means is that every point on the parent function, okay, now how many points does this function represent? Okay, again, infinitely many. When we connect points, we're representing infinitely many points, but we're going to start with these 7. Okay, every point on the parent function moves 2 units to the right. So this point, and what do we call this point? This is called a vertex, okay, and its location is at 0, 0, okay. Every point moves 2 units to the right. So we're going to start with the vertex. The vertex is the most important point. The vertex moves 2 units right, so the vertex moves to this location, okay. We're going to label the new location as the vertex of the new function. And this vertex is not at 0, 0, but this vertex is at what? 2, 0. Okay? Every point moves 2 units to the right. So we're now going to take this point 2 units to the right. Okay? And you should be following along on a piece of graph paper. All right, this point 2 units to the right. And one more. This point 2 units to the right, to complete this side of the V. Now, going to the other points, okay, this point, 2 units right, puts us here. This point, 2 units right, we are located now here, and this point, 2 units right, here. Okay, so let's graph it. And notice, okay, so we now have the member of the family graphed 2 units to the right. So now let's label each function. The original V was the parent function, y equals the absolute value of x. Okay? And this member of the family, notice that the member of the family has the same size and shape as the original parent function, but is just translated 2 units to the right. So we're looking at this second v to the right is the equation y equals the absolute value of x minus 2. Okay? So you understand there are 2 different functions graphed here. Okay? We have the parent, and we have the member of the family that looks just like the parent. It has the same size and shape, but has just been translated 2 units to the right. Now, okay, so what do you guys have to do for homework? Well, you guys are going to be graphing members of the family. The directions are as follows. First, you will graph the parent function, and then you will slide your points 2 units to the right, or whatever direction you have to slide. We're going to talk about different directions here in a minute. And you will label the vertex of each function. Okay? We're going to talk about how the vertex is going to save us a lot of time in the future. You're going to get tired of doing this. Okay, but the vertex is going to be the key to saving us a lot of time. And then you will label each function. So the rules for this class are, whenever there are 2 functions on the same graph, we label each function, okay, so that we know which one is which. Notice this second function is y equals the absolute value of x minus 2 is labeled up here so as not to confuse. All right, now, so I'm going to erase this. You can always rewind the video if you need to look at that again. And so again, notice it was the opposite of what we expected. So 2 being subtracted inside the absolute value results in a translation where? 2 units to the right. Okay, now, what if we have this? Y equals the absolute value of the quantity x plus 2. Hopefully you can say, well, minus 2 means 2 units right, so plus 2 means 2 units to the left. So if 2 is being added inside, this results in a translation. We don't need to write the word translation every time. I'm just going to highlight this point. This is 2 units left. Okay? We also have y equals, well, maybe here, before I go further, maybe this makes sense. hopefully you remember the geometric method that we used earlier this year, so as not trying to confuse here. This is completely different but similar. Okay, if we were looking at the absolute value equation earlier this year, absolute value x minus 3 equals 5. Remember that we found a center. Okay, remember that the center was the value inside. And remember that the center was opposite. So if we have negative 3, the center was what? Positive 3. And the distance either way was 5, 5, and we got the solutions 8 and negative 2. Okay, so our solutions were 8 and negative 2 are the values that make this true. But notice, the center was what? Opposite. Okay, so minus 3 meant positive 3. Maybe that will help you as you try to recall this. Okay, notice minus 2 inside means 2 units right, plus 2 means 2 units to the left. Now, let's look at this. Y equals the absolute value of x with 2 being added outside. So notice the difference. Notice the difference. Okay, so here 2 is being added inside. Here 2 is being added outside the absolute value. Okay, so I always tell students this. Do the opposite of what's inside. Okay, so what's inside, when something's being added inside, this results in a translation left and right. Okay, and we do the opposite. So minus 2 means right 2 units, and plus 2 means left 2 units. Now, when something's being added outside the absolute value, okay, this results in a vertical translation, either up or down. Do what makes sense. Do not do the opposite. Plus 2 means 2 units up. Okay, so plus 2, 2 units up. Y equals the absolute value of x. Subtract 2 means what? Hopefully you say 2 units down. Okay, so let's recap. Again, subtracting inside results in a translation left or right. Okay, so we have minus 2 means 2 units right, plus 2 means 2 units left. It's the opposite of what you expect. On the outside, it's not the opposite. It's exactly what you expect. Okay, so adding 2 means 2 units up, and subtract 2 means 2 units down. Okay? All right, now, erasing this. If you need to, you can rewind. And we're looking at this function. Y equals... Y equals the absolute value of x, subtract 3 plus 2. Okay? And so what we're going to first identify is our translation. Notice something is being subtracted inside and something is being added outside. Maybe put this in the notes. Translation or slide means something is being added or subtracted. Okay, so something being added or subtracted results in a translation or a slide. Again, dilation, reflection will be covered in the next video. Now, subtract 3. Remember, we do the opposite of what's inside. What's inside is our left and right, and what's outside is our vertical. Okay, and we do what makes sense on the outside. So minus 3 means 3 units right. Okay, and plus 2 means 2 units up. Again, the directions for tonight's homework are to first graph the parent function. Okay, so we're going to start, well, you know where the points are located. Okay, so I'm going to quickly draw this. Okay. At 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3, and this piece. Okay, standing back so you can see. Again, this is the parent function. We label the vertex. Okay, the vertex is at 0, 0. Okay, and we label the function itself. The equation of this function is y equals the absolute value of x. All right, now, we're now going to graph the member of the family. Remember that this member has the same size and shape as the parent. It has just been translated 3 units right, 2 units up. So every point on the parent function is going to move 3 units right, 2 units up. So we're going to start with what point? The most important point is the vertex. So 3 right and 2 up puts us here. And as soon as you move the vertex 3 right, 2 up, I want you to label this. Point is where? At 3, 2. Okay? Now we're going to take this point, 3 units right, 2 units up. This is here. and this point, 3 units right, 2 units up. Sometimes if you run out of space, okay, there were 7 points, 1, 2, 3, 4, 5, there's 7 points given on the parent function. I require that you translate a minimum of 5, okay, so we're, again, at least the first 5. If you can fit all 7, that's great. So the vertex is the most important, 3 right, 2 up. This again here, and then this point, 3 right, 2 up here, okay, 3 right, 2 up here, and now this point over here, 3 units to the right, 2 units up, and then this point, 3 units right, 2 units up, and you will notice that the member of this family that we just graphed has the same size and shape as the parent, but has moved 3 units right, 2 units up. Let's go ahead. We've labeled the vertex of this family member, and the equation of this function is y equals the absolute value of x minus 3 plus 2. Students say, well, I wrote it there. Well, put it next to the function. Okay, so I'm sure that you understand the difference between these. These are 2 separate functions. Okay, both of them V-shaped. Let's see, in this lesson, I think that wraps this up pretty much. Maybe one more quick example. If you're done, you can probably just go to your homework now, but for those that maybe aren't getting it yet, do one more quick example. Okay. Let's do this one. Y equals the absolute value of x plus 1 minus 2. Okay. Okay, on the inside, we do the opposite. Plus 1 means 1 unit left, okay? And the subtract 2 on the outside, this is your vertical. We do exactly what makes sense. This is 2 units down, okay? Now let's go ahead and graph. First, the parent. The parent function is located here, okay, at 0, 0. 1, 1, 2, 2, 3, 3, okay? Negative 1, 1, negative 2, 2, and negative 3, 3. Okay. Most students tend to find this lesson fairly easy because it's more geometrical. They can see it, you know. So hopefully, if you're a geometrical thinker, you can see what's happening here. Okay. And again, we label our vertex. These are what students forget. They forget to label the vertex. Vertex is at 0, 0, and the equation of this function is y equals the absolute value of x. This is again the parent. And we're translating every point to graph this member of the family. We're translating every point 1 unit left, 2 units down. So starting with the vertex, 1 unit left, and 2 units down. Okay. Oh, I'm in the way here. Sometimes you may have to think ahead. I should have been thinking ahead. The vertex of the parent was at 0, 0. We have to go 1 unit left, 2 units down. So 1 left, 2 down puts us here. Label this as the vertex. And the vertex is located where? The vertex is at, hopefully you say 1 unit left, 2 units down is negative 1, negative 2. Okay? And now every point. Okay, so this point, 1 unit left, 2 units down, puts you here. 1 unit left, 2 units down here. 1 unit left, 2 down. And one more. 1 unit left, 2 down. We graph this function. Okay. Again, it has the same size and shape as the parent. It has just been translated 1 unit left, 2 units down. And the equation next to this function is y equals the absolute value of x plus 1 subtract 2. All right, great. That concludes this lesson. Good luck, guys. Next lesson, we're going to go much more in depth with this. All right, great.